Hey everyone, welcome back to the channel. In today's video, we are going to discuss about the flaky tests in CI/CD, which is the pipeline such as the Jenkins and so on. So we are going to give you some tips, the causes why flaky tests occur and how to manage them and some solutions. So let's dive into this topic and let's go. So first of all, what is a flaky test? A flaky test is a test that sometimes passes and sometimes fail. What this means is in a week, you might see the test pass 2 times and fail 3 times, and there is no apparent reason or pattern, right? It reduces the trust in the CI build and automation. So when a developer or a QA sees a smoke test failing in the pipeline, they just say, just rerun the build. And that means your CI is broken and they don't know whether the failed test is a bug or not. So that's why it destroys trust in CI systems. So developers start ignoring the failures, and what is the end result? Even a flaky test covering a critical workflow is failing. So that is even worse than having no test at all. Qualities of a good test. When you write a good test, how can you tell it's a good test? It should be self-checking. Test framework does the work for you, and some call these as the automated checks, but the terminology doesn't matter here. The automation is what does all the verification for you. So you can make sure that the code is safe to release to the next stage. And another quality of a good test is the fast execution. It runs quickly. It should run as fast as possible. That's the real goal. And for faster execution, of course, you need to enable the parallel execution. In some scenarios, you cannot parallelize. A good test should be isolated. What it means is the test data used by the test, each test should be independent from other tests and so on. So you need to make sure that your test is completely isolated. For example, you might have a test that shares a date or a other environment variable that is shared by other tests. So you might be running a smoke test, and other department might have a automated smoke test that might change the date in the database, and this might cause your test to fail. So this dependency should not be there in a good test, especially in a smoke test. And of course, it doesn't depend on data. It might be depending on other systems also. Sometimes the API might be down and it might not be up during the day. In other words, during the night sometimes. So without isolation, the test failure cascades. So, and another quality of a good test is repeatable. A repeatable test should be consistent, should give consistent result every single time. Let's say you run it 10 times, you should get the same result every time. It passes consistently or fails consistently, that doesn't matter. Consistency is what matters. And flaky tests violate this fundamental principle. So these 4 qualities are your foundation. So if you miss any one of them, you will pay for it later. So let's now see the common causes of flakiness. The first thing is the timing issues. The issues might be due to network or some changes in the UI, HTML ID changes, and your test might not be having that capability to heal itself automatically. So the frameworks might claim that no waiting is needed, but really you need to make sure that you have the dynamic waits and no hard-coded waits or thread.sleep lines. And you should always check for edge cases and make sure your test is resilient in those. And that's a fundamental problem. The problem is, when do you know the UI is finished updating, or a button appears in 1 second and sometimes 3 seconds. So that's where the elements on the page you need to observe and make sure you have the dynamic wait. And then you need to know when the network request gets completed. So you need to wait for a clue on the screen or some other network response, and then wait until you get that response. And figuring out how long to wait is the fundamentally hard issue here. And the network also causes the chaos, and anything your app touches, the UI might talk to a DB, database, or APIs, or some other remote endpoints, and it might even make a GraphQL request. So that's what you need. And another thing is it might be due to infrastructure, your environment, or could be some external service. And another thing is the resource constraints. This is the limited test environment capacity. Suppose you run your test in test environment, but your environment doesn't have the Jenkins agent, or your machine where you run is not having that capacity to run those tests in parallel, or if there is any inherent limitation in the memory used by the computer, the machine, whether it's Unix or Windows machine, or the CPU is not that much powerful, you might end up in the resource constraints. So sometimes you might have experience when you are working on a project, you might need to tune your environment for many weeks. So you need to make sure that your test environment is really have that capacity to handle those parallel test runs. And another reason is the version mismatches occurs between the application and the test environment application. And there are some dependency conflicts, and there are some backward forward compatibility issues, and you need to make sure that your library version or any protocol and any dependency that your test uses, whether it's software or environment, need to be aligned with what you need for that test. You might be using a Lambda version, for example, deployed in production, but your test environment has a outdated version. We need to make sure that all the dependency, the APIs, the database refresh is the latest one. So you make sure that the tables have the columns and they are not outdated. And of course, the rare framework bugs, they are very rare, and you need to patch those. Don't apply the patch actually. If found, you should report to the upstream. So those are the framework bugs. And the library glitches, for example, the dependency library or the shared library need to be up to date, and any bugs in the library might impact your test, and it might cause it to behave in a unfamiliar pattern. That's what we call the flakiness. So many of these problems can also happen in the production. So that's what the flaky tests make valuable. Sometimes flaky tests, they are the signpost to real problems. So you cannot just ignore a flaky test and just take it as a low priority. The flaky test may actually point to real performance issue or some other bug that might be even reproducible in production. And let's see why the flaky tests matter. They, of course, destroy the trust in the CI/CD pipeline. Developers stop believing the test. When the test fails, developers say, just rerun the test, as I mentioned before. And this culture is not good. And also the flaky tests hide the real bugs in your code. You might think, the test passes now, so it must be all good. But when you look at the screenshot of the failure, it might be a timeout issue to a remote API that the UI calls. So there is a performance issue there. So you hide some non-functional issues that you might not have a chance to fix it, and it might end up in a big issue in production. And that might be one of the critical flows too. And it might slow down development. If you just keep rerunning failed tests, that's an additional time. And if you add throughout the months and years, you might see hundreds of hours wasted on rerunning those tests. And of course, the build time explodes and the productivity suffers. And team sometimes comment out the flaky test, they forget it, we sometimes disable the flaky test, and developers also think, hey, if I write 20 test cases for this sprint, obviously some are going to be flaky. Let me write fewer tests. So they end up frustrated with the system and they write fewer automated tests. So it's a vicious cycle. Do not have the flaky test as a low priority. You need to identify the flaky test by constantly monitoring the nightly test, or it be a smoky test. You need to take note of it, how frequently it happens, and you need to prioritize this. And failing sometimes, the flaky test fails sometimes due to stability issues. And you should always make sure that you not only identify the flaky test, you need to make sure you give ownership to the right developer. And you need to fix the root cause systematically. You need to really analyze where is the problem is, so you give a long-term fix rather than patching it up with fixed hard-coded wait times. And you need to confirm the stability to retesting. Most of the time this is another problem. Developers or testers, they fix the test and then they run in the local machine once, and then they create a pull request and it gets merged, and then the next day the same test fails again. Why? How can we avoid this? When you fix the test, you need to run it several times and make sure that it passes consistently. You need to make sure that your fix is stable. Otherwise, you are going to keep fixing the same test, and this is not an efficient way. And let's see how you can detect flaky test. Some of the tools available are Datadog, Velocity, build logs. These are the application logs, and you can even directly go into the Jenkins and see the exception and see what type of exception you are getting, whether it's a stale element exception or any wait timeout or completely a gateway timeout page you see in the screenshot. So these are the things. You need to also focus on the intra-run flakiness. What it means is the tests that fail within single build and they are auto retried. You need to make sure your framework has any auto retry. So you need to make sure that you have the auto retry and it also logs how many times it is retrying. But the only problem is the retrying slow test is expensive, and also retry is not recommended strictly speaking, because a retry might automatically test the retry and the test might pass, but it might hide the real bugs. When you have to look at a particular test that is flaky, is it a slow test? Is it using more resource intensive test? Those slowest, most resource intensive tests are the flakiest ones. So you need to go inside the test and see if you can break them down into smaller tests. So the smaller the test is, the more stable the test is naturally. So you need to look into those intra-run flakiness. And then there is another one called the inter-run flakiness. This is the failures across multiple builds. So you need to consistently see if a test passes in run 1 and the same test passes in run 2 and then again passes in run 3. So this requires historical tracking, and this is more informative. So you need to monitor that across the builds. And another type of detection strategy is historical analysis. You need to review the past test logs for any pattern, and this is again pulling the third-party data into your system, and you can see what are the data it is depending on. So you can isolate the data and make the test independent of those data, or simply isolate them and run them separately. And when you look at these tools, you get a unified view also. So you need to make sure that you detect these things early and fix them as soon as possible so you can move faster. And the next thing is the assignment. This is a major problem and we need to address it through some tips, as we can see. So usually when you assign it to nobody, you say that you need to say, you should not say someone will fix this. You need to assign ownership. Like I said before, one clear developer responsible or one QA responsible. This is the core principle. Someone must own it. They must be aware or else they won't fix it. And if you avoid group assignments, if you say team 1 is going to fix the payment scenarios and team 2 is going to fix the login scenarios that are flaky, and within the team they might blame the QA in the team 1 might blame the developer in the team 1. So it's a Spider-Man meme effect, if you can recall that meme. So it's always explicitly assign the owner. And the next thing is the use code ownership. You can see the Git history when you open a test, and if you see it in your IDE or if you go to any browser, Bitbucket or any code, you see the code history and it shows you who made the change, recent change, and who broke the test, literally. So you know who owns the code. So that way you can see who made the last commit. So this is also another way of finding the owner and then pointing them. It's not a blame pointing, but it's good, so you can directly go to the individual and he knows them best because he made the latest change and he can fix it pretty fast instead of giving it to another team member. So accountability matters, right? You cannot just say it's not my job and QA is pointing to developers and vice versa, and in the end nothing gets fixed. So the only solution is one clear responsible individual. Reassignment is okay, but you need to make sure the clarity is there and there is no confusion. So flaky test is just like another bug in your automation, and you should not pass it around until you find the right person, right? So you might assign to a first person and he might not be able to fix the code. That's okay, you can give it to some other individual who is well known with the story, the Jira story associated with the test case, or you might know the business requirement better than the other person, and that is fine. Is the resolution. How are you going to resolve the flaky problem? The first thing is the quarantining the flaky test. If you see a test fails and it is flaky indeed, you need to temporarily remove from the nightly test or smoke test. So the build is green, and when you quarantine, you can focus on the flaky test. Though the flaky tests don't break the CI and they are not in the critical path. And you can also use annotations, some automation frameworks, or you can create your own custom annotation, and you can mark those flaky tests as, annotate them as flaky, so the framework can skip those tests. And you can also create a centralized block list. You can create a text file or an Excel spreadsheet where you can list out all the excluded tests in one place, so you can make sure you can track who fixed it and what is the status of the flaky test. So that's what it is. So when you annotate and when you centralize, you are actively putting those flaky tests in your sight, because when you ignore them, out of sight is out of mind. The centralized block list is, you can create a text file, as I said, and Selenium does this officially. You can maintain a script test, and then in the test, if you can read the text file and say if the test name matches, then don't run this test. Throw a silent exception and print a log saying that this test has been ignored because it was in the script test list, in the script test text file or similar file. So developers can still run the test locally, and they can be it is more flexible than annotation. You can use annotations, or you can use a custom list of tests in your file, custom text file, or an MD file, or any plain text file. And your test can read those for test file, and then it will ignore the tests that are listed in that file. But the disadvantage is you need some coding here, some custom logic there. But the quarantining, the basic benefit of these things is that when you quarantine, you buy some extra time to fix it properly. So there is no rush in putting some hard-coded wait and then saying I fixed it. You need to really have the resource and time, but it pays off in the long run. How do you actually prevent the flakiness? It's pre-verification. When you create a new test or when you update a test, you need to run it many times before merging it into your master code. And another thing from my experience is you should not only make sure it runs multiple times, it passes multiple times in your local IDE, which can be Eclipse, IntelliJ, or Visual Studio Code. You should also run the same test in your Jenkins or other CI/CD that you have, and make sure that it is stable there also. So this is guaranteed, not 100% guaranteed, but it gives you that confidence that your fix is really a stable fix and not another fix that you need to make again. So it saves you and improves your productivity. The gatekeeping is someone has to, before merging the PR, you need to make sure a member of your team checks this. Suppose you run a test multiple times and it passed, you need to attach the screenshot of that pass screenshot that you have proved that the test is indeed. So if you are the one that has the authority to merge the automated test, you need to be the gatekeeper. You should say, unless you attach a screenshot of the test passing multiple times in your machine or in your Jenkins, which is more makes sense here, you should say, only when I see that screenshot, the evidence that your test ran multiple times and succeeded, only then I'm going to allow the test to be run in the CI/CD, or allow the test to be even merged into the master code. And the third tip to prevent the flakiness is improve timing reliability. When you create a test, you need to go work with your developers and see what API the UI, the web application, calls in the backend behind the scenes. So you might know where to apply the dynamic weights, and you need to also make sure that you're using all those best practices, and make sure that your test environment health is also good, and so you're not running the test in an overloaded infrastructure. So these can cause the random flakiness. The unstable environment result in more test failing randomly. And the another reason is the healthy deployments. You should avoid stressed deployments. That's what I said here. So when you have an environment that doesn't have the capacity to run those tests in parallel, you might have to see these broken builds. So you need to make sure that your environment is healthy. Your machine agent has the enough CPU memory to run your test. So you might run the test in parallel with the goal of running the test faster. But if your environment cannot handle it, it's going to run them slower, or it's not going to load the browser, for example, and it might throw some driver exception. So how to rerun and do the retry strategies, some of the strategies. The first strategy is the selective retries. Rerun only the failed tests, not all. Again, some frameworks support it, and if your framework doesn't support it, you might need some custom logic. So you need to rerun only failed test. If the test fails 5% of the time per run, you need to have a strategy to rerun them automatically So there's a little bit of luck involved here. So you need to pick the slowest, most flaky test. They should be retried and not all tests. And of course, rerunning the test is expensive. It causes the build time to be more longer. And the flakiest test are the slowest test and the test that use the most resources, as I said. And when you retry, you are making your slowest test even slower. So if your test run for 5 minutes and if you rerun it, now you're running the test for 10 minutes. So it's doubling the time. And if it's going to retry 3 or 4 times, you get the point. And then you need to set the SLA thresholds. You need to define what is a flaky test. For example, if it fails 1 out of 4 builds or 30% of the time, you need to make sure if retries exceed SLA, then don't retry. So that's what you need to maintain, that balance, the number of retries versus the speed of your test. And also you need to monitor your build. As I said, how long a test runs, you need to make sure how to set the retry logic, whether you need to rerun them, retry 2 times or 3 times. And then the smart back off. You should avoid cascade failures with retries. If your test is every time you add a retry, right? Suppose if you are retrying everything, a flaky test might cause a retry mechanism to kick off, and it might retry, but it might end up cleaning the same test data that is shared by another test. So that's why, like I said before, you need to make sure your tests are isolated and the test data used by one test is not dependent on other tests. Otherwise, rerunning a flaky test might break other stable tests too, because they are sharing the same APIs, the test data, or other shared data. So you need to make sure your test is isolated so you can avoid this cascade failures. And let's talk about the smart execution of the test. You should run only the affected tests. Flaky tests might be 10% or 5% of your test base. You run only those instead of running all affected tests. So this is one of the smart ways to make sure that you save time and you run only the affected tests. So your framework will support this, or you can simply call out those tests in your run command. And another thing is the historical correlation. You need to track which test failed with similar code change. You need to organize by components, and when you're in a particular component, a login component or a payment component or a logout component changes, you can predict what test needs to be run. So you run only if a login page code changes, you will run only the login suite that has the login 10 or 15 login tests. So you don't run the whole test. So this is another smart way. So if your payment page code has changed, now we need to run only the payment page scenarios and maybe the login logout scenarios. So you predict which test will be impacted, and you do this, of course, by looking at the changes. So this is not a perfect way, and there is no reliable method exist, and that's what. So you need to make sure, do we need to move fast or do we need to move safely? So you cannot do both at the same time. So if you are conservative, you need to run all the tests, run or more tests, accept the flakiness risk. And if you are really aggressive, you need to run a few tests and then skip the tests that are not affected by the code change. So there you accept the coverage gaps. So the thing you need to do, the mitigation, is periodically run all tests to validate that you are not hiding any bugs. And that is all about the smart test selection. So you run fewer, and there are also AI assisted optimization. There are machine language algorithms that you can leverage for smart selection. What this means is the machine language scans your code, and when a code change, and then when a code change comes, it runs the test and sees which tests are impacted by the code change. It does the machine learning analysis, and it analyzes all the test runs over a period of time, and then it learns. And then when the learning is complete and now a new code change happens, it can intelligently select. That's what it's called, the smarter selection. The AI assisted machine learning, that algorithm will now select the smart test and run only the subset of tests that are really affected by the recent code change. This might sound smarter, but there is a slight risk because the AI is not that perfect, but it is almost reliable, and you need to make that decision whether you want faster builds or you are taking the risk that you have 10,000 tests. Now the AI is telling that you need to run only 50 tests. So you need to make sure that you need to test this out many times before actually implementing. You need to do a POC and make sure you do this before actually implementing into your production automation code. And then another thing is the reducing this build time. You need to run only fewer more targeted tests. That obviously reduces the build time. So it's about the trade-off, whether you want to run all the tests periodically so you are not hiding any bugs, or you are running only few targeted tests. Again, this can be based on the commit history or based on your decision, based on your experience. And let's talk about the test size and quality. Small focused test. So when you have a large test that has hundreds of lines of code, that is more prone to flakiness. When you have small focused test that has single responsibility, let's say you have to test a user creation, and you are going to have all the types of users created, and it has hundreds of lines. Instead of that, focus on single responsibility. If a test is creating a customer, then you need to have the test only for that. You cannot add a lot of permutations, or you cannot add other types of scenarios like creating a single customer or creating a married customer profile or a retired customer profile. You can split those tests. If you see in general a test spanning hundreds of lines of code, you need to look into those tests and make them small. And another way is the test pyramid. You need to favor unit test over integration test, and of course integration test over the UI test, the end-to-end test, because the unit tests doesn't have that flakiness. They don't have that. They don't interact with the UI or other brittle elements or unpredictable elements. So that's the only thing you need to remember. And consolidate redundant tests. That is what this means, is you need to remove the duplicate coverage. This is very helpful not only in saving the build time, but it reduces flakiness ultimately. If you have a test that creates a user that logs in, logs out, and some other test is also doing that login, log out, you might want to think, can I log in some other way by calling the API instead of going to the login page? And another scenarios, you might see some duplication. So you need to carefully examine your bigger test, whether you need to break them into small tests or take away the duplication, which might be the real issue. And also you need to delete the unnecessary test. When you have a lot of tests and you don't monitor them or regularly take a look at them, your test, there will be some dead code build-up. So you need to have a monthly or quarterly examination of your test suite and delete unnecessary tests, because the scenarios may no longer be valid and you are simply having a dead code. That's what it's called. The code is there, it runs fine, but that is of no use because the functionality is retired, or it might not be failing, so you don't know. You might think you have 10,000 tests, but the 5% of the tests are unnecessary, and it's wasting your time. The build time is increasing unnecessarily. And the next one is the verification. Flakiness is not a permanent problem, it's transient. So you need to periodically rerun to test the stability over time. So rerun tests that are marked flaky regularly. So is it stable or is it still flaky? So it gives an accurate view of your code base. And of course, this also makes the test stable. And the next verification is the environment health. You need to validate the dependencies and the infrastructure. So validate your environments. You need to check the DB, whether your database is up, the API is up and running, and all your services in the cloud are healthy. And you need to check all these dependencies. If the dependencies are down, you need to make sure that your test fails fast. And you need to make sure there is nothing wrong, something else going on in the environment. And the flakiness is, as I said, it's transient, and issues may resolve on their own sometimes. And re-enable stable test. You need to make sure that the fixed tests are running back in the CI. And so you need to make sure the ignore annotation or the tests that are listed in the ignore text file that I mentioned before. You need to make sure that once the test is stable, you need to remove those ignore annotation so the test is not ignored and it comes back into the CI again, and you can see the test is being used and it's not accidentally ignored forever. So we discussed a lot of items. So the key takeaways is the flaky tests signal deeper system instability, both in the code and infrastructure, and you need to handle them systematically. You need to go and detect, and you need to assign the ownership, the right owner, and you need to make sure you resolve and monitor and verify that your fix is indeed stable. And of course, the prevention is the key. You need to verify it before every CI or every code merge, and you need to implement smart retries that are selective retries, and you might even implement this setting the threshold and monitoring the impact, and also make sure your test is small focused test is more stable than large test. And you need to maintain the CI trust. This is the most valuable asset. So when your CI is passing and there is no these flakiness are fixed, developers believe in the system and they believe in the test coverage. And the test reliability is a team priority, so it directly impacts the team productivity. And of course, the flaky test is not a QA problem. They affect the entire team's velocity and morale. So taking time to look into fixing them pays you big in the long run. So you need to invest some time and resource so you get the dividends. So thanks for watching. We have seen a lot of useful information in the video. So if you like this video, please share it and subscribe to the channel, and drop your thoughts in the comments below. And what is your experience with the flaky test, and do you have any other ideas on how you overcome or managed it successfully? Thank you for watching this video, and happy testing.